Let's revisit this discharge business that we discussed already before, but now in the context of whether that long lead can help us with improving predictions. So just to remind ourselves, the 2013 paper by Nandini looked at the discharge along the tropical Pacific equatorial region, averaged over 5 north, 5 south for June, July, August of the previous year. So it would be June, July, August of 2025 for this El Nino. And these are for different regimes, as we called them before, 1958 to 1976. So June, July, August, September, October, November, December, January, February, and March to May. And this looks like what we are seeing right now in the 2026 case. But if you go to the 1977 2000, they look much more disorganized, because here these anomalies are computed with respect to the long-term climatology for the whole period from 1958 to 2011. And you can see that probably makes you wonder whether discharge, recharge are such a fundamental part of the El Nino cycle. But back into 2001 to 11, you see that again things are looking similar to before, but maybe looking too powerful, too strong, beginning 1 year or almost. If you think DJF of 26, 27 will be the peak, June, July, August of the previous year is 16 to 18 months before. So even from the beginning, they look very strong. And she did a very simple calculation that El Nino actually rectifies the background state. So we have to use climatologies of each period. And when she does that, it looks much more systematic for all regimes. And the argument of the paper is that the recharge discharge, in fact, is a very intrinsic fundamental process of El Nino cycles, except that stochastic processes, westerly wind bursts, are still important. And she looked at some of the failed El Ninos in her framework and argued that even if discharge starts 18 months before, El Nino may not happen because of these missing westerly wind bursts, something like 2014, which seemed to want to grow but then died away, maybe because it didn't get enough westerly wind bursts, right? So this just means that discharge is a necessary condition for El Ninos to happen, but they are not sufficient. Discharge by itself doesn't guarantee an El Nino. So how can we use that? If you look at the differences for May 97 and May 2014, they look very similar, except maybe this is much warmer, and yet this one basically fizzled out, whereas this turned out to be a very strong El Nino, strongest of the 20th century. And if you look at forecasts again, this is for 2014 that we mentioned in the last little podcast, that 2014 didn't quite grow, but 2015 did. So can these forecasts have been corrected in some way based on whether the discharge happened correctly or not? In other words, if discharge in fact did start in the previous summer or fall, so if 2013 had seen the onset of discharge, could it have given us more confidence in saying what 2014 should have done? You know, the fact that it didn't get stochastic forcing and westerly wind bursts may end up making it a weak El Nino at best, whereas here we saw already that westerly wind bursts grew. They didn't go very far east of the dateline as they did in 97, 98, but nonetheless it got relatively strong in 2015. So I hope you understand, but we can understand this a bit better. So El Nino SSTA intensity and Northern Pacific meridional mode, which is a different issue, we'll come back to a little bit later on. But essentially, you may be starting at different levels of the Niño 3 or ONI index in the let's say, initialization. These are initializations at different periods. So basically, ocean sees the up-to-date conditions, and next few months are forecasted for Niño 3. It's a global prediction, but you look at Niño 3. In statistical models, it's much more focused on just predicting Niño 3 using various approaches. But nonetheless, do these differences matter to as to where the El Nino itself will go, and whether models are able to successfully predict it, or whether the stochastic forcing will be needed beyond the onset? So can onset somehow help? And the best way to look at it is these ensemble members. So this is the evolution of Niño 3.4 again in October 12, so up to October 12, 2012, and then the Niño 3 crashed, and the model forecasts started in October 12 were all over the place, and you can see that some were going negative, some were going positive, and the ensemble mean would have been basically neutral. But if you looked at the same year in the August forecasts, so this is the same curve here, August forecasts were very confident about the El Nino forecast because all of them were saying positive. So is it possible that discharge didn't happen, and we could have used it here to say these positive forecasts are not reliable because the discharge hasn't happened at all? So the sufficient condition is not met, so we can somehow weight the ensemble members in a correct way based on the onset of the discharge. This is my hypothesis, but obviously operational prediction people said, we are not going to bother with that, but maybe some of you can make this simple exercise in hindcasts to see if onset of discharge, which is easily visible because when you are initiating here, you already know whether the onset has happened or not, and here also you know because the onset of discharge would have happened in 2013. So can we use that information somehow? That's the point. The point of showing this was to say that there is something called the Pacific Meridional mode with all kinds of details that I'm not going to get into, but we mentioned it already as some extratropical sea surface temperature anomaly that can generate tropical responses, and it persists through the season. So it's called seasonal footprinting mechanism, and it is argued to be something that can produce stochastic forcing or westerly wind bursts, and it's even argued that this is what is now being called the Central Pacific El Nino, and it's basically a version of the Pacific Meridional mode. Basically, it comes back to the confusion and the ENSO theories, which means there is no unified theory that everybody agrees on because different processes dominate in different El Niños. So El Niño diversity itself is related to that. Okay, so we'll come back and look at the intertropical or pantropical interactions because they are also critical. El Nino happens in the tropical Pacific, but we know that there are zonal modes in the Indian Ocean that we call Indian Ocean dipole. Atlantic Niño exists. Are they really independent? And there are lots of papers arguing that Indian Ocean dipole actually affects the evolution of El Nino. But if you remember the Indo-Pacific tripole, then maybe they are just evolving together. But local interactions and local strong coupling in the Indian Ocean can make the Indian Ocean side of the cold tongue in the Eastern Indian Ocean can maybe affect the Walker cell and a growing El Nino. We are always worried about these things because the predictions can improve if we can understand all these things, right? Right now in 2016, an IOD is supposed to evolve. Typically it peaks in September, October, November, as we said. Is the IOD evolving independently, or is it part of the strong El Nino itself? Because 97-96 also had a strong IOD associated with it. An interesting thing is even though 97-98 was a strong El Nino, monsoon didn't have a deficit, and this year we are watching closely to see if IOD will evolve and help the monsoon. But so far, as I'm recording this on 19th June 2026, monsoon is a disaster in terms of just being stuck, and the deficits are somewhere around 50%, I think, but June only contributes about 15 to 20% of the seasonal total. So monsoon can still recover quickly in July, August. Of course, total amounts are only one thing. If distribution of rainfall comes with extremes, heavy rain and droughts, then that's not going to be very helpful. Anyway, just think about onset of discharge and prediction improvement possibilities. Okay.